Hello everyone, I am Tejaswani Dash. In this Teach 1 session of HAP 671, that is Healthcare Database, I will introduce you guys with a topic called Query Optimization taught by Dr. Farrokh Alemi. Historical background. Cost-based query optimization was invented by Pat Selinger as part of the IBM R project in late 1970s. Database management system was the hardest part in building in last 30 years. Progress was difficult, but later became feasible because of fast hardware and fast database management system software. So, we are talking about optimization. But what is optimization? Optimization is the process of making a design or system by using the resources effectively. Now the question comes, what is query? Query is a request for data. It tells us what is there in the data. How do you formulate a query? For example, how many Rolling Stones albums were produced before 1980? We write queries according to the questions we have on data. After going through query and optimization separately, now comes the term query optimization. So I would like to raise the question, what is query optimization, or what do you understand by query optimization? The query optimizers attempts to determine the most efficient way to execute a given query by considering the possible query plan. This is query optimization. So what are the important tools of query optimization? There are two important tools of query optimization. First is execution plans. Second is statistic input-output. Execution plans. SQL Server query performance tuning is considered as a top priority and an endless battle for database administrators to achieve the best performance for their managed systems with the least resources consumption. The first method that any database administrator recall when thinking about the query's performance tuning is using SQL execution plan. An execution plan provides a graphical representation of how the query optimizer chooses to execute a query. The execution plan shows us which table were accessed, how they were accessed, and how they were joined together, and any other operations that occurred along the way. Including the query cost, which are estimate of the overall expenses of any query component. A treasure trove of data is also included, such as row size, CPU cost, input-output cost, or details on which indexes were utilized. Statistic input-output. Statistic input-output allows us to see how many logical and physical reads are made when a query is executed, and may be turned on interactively in SQL Server Management Studio. Let's take an example how this works in simple terms. Let us take Q1 as query 1, Q2 as query 2. Query 1 would result number of cities in the data, and same number of cities results comes from query 2. Now, instead of running two different queries on database twice, which consume the memory and computational power, let's take the statistic input-output that allows to take second query to pull out the data from memory hardware to save computations of the system. What does the query optimizer do? So there is a basic process channel for every execution. So for query optimizer also there is a process where parsing comes first, then binding, then optimization, and finally we get execution. So if we talk about parsing, parsing is the process by which query syntax is checked. Then binding is the one which checks all objects referenced in your TQL against the system catalogs and any temporary objects that defined within your code to determine if they are both valid and referenced correctly. Now third comes optimization, that we are going to look into our next slide. We will talk briefly in our next slide. So the fourth comes is execution. Execution is the final step. SQL Server takes the execution plan that was identified in the optimization step and follow those instructions in order to execute the query. Optimization. The optimizer operates similarly to a chess or any computer gaming. It needs to consider an immense number of possible moves as quickly as possible, remove the poor choices, and finish with the best possible move. At any point in time, there may be millions of combination of moves available for the computer to consider, of which only a handful will be the best possible moves. Thank you for listening.